Hello my dear students, please subscribe our YouTube channel for more free video lectures and click on bell button for notifications and visit our website to purchase full course.
Hi friends, welcome back to the session of computer networks. So we have completed in the last few sessions about fundamentals like datagram, virtual circuit, what is circuit switching, message switching and packet switching, and different kinds of topologies and different kinds of mediums. Now in this session we focus into what is the importance of layer structure. Why? Because every network, any kind of a network, not only computer network, follows layering structures. You say, for example, IoT is following layering structure, like 5-layered structure, and you follow TCP/IP is following by computer networks, and X.25 is following some other layer structures. So every network has to follow some kind of layering structure. Why? Because layering structure is going to provide only one thing, that is abstraction and encapsulation. So abstraction and encapsulation is mandatory before you push the data to the receiver. So who can do this abstraction and encapsulation? That is done by only layering structure during your data transmission from one end to other end. So N1 and N2 do not know about what is happening during the data transmission. So sender and receiver least bother about what is happening during the data transmission. They are only mostly bothered about how to send and how to receive the data, that's it. But the rest of the care is taken by your layering structure only. So what the layer structure do? I said very two important principles, that is abstraction and encapsulation. And other point is that every layer has a mechanism to identify who is the sender and who is the receiver. And as we know, every layer is associated by protocols. So finally, protocols one end, layers one end together forms network structure. So that's why while you are talking about communication from one end to other end, nothing but data transmission, then it has to follow layering structures, because data transmission will not be done directly from node 1 to node 2. It's done by one chronological manner, first layer, then next layer, then next layer, then next layer, then only finally data will come to the media. So media is the main responsible to push the data from one end to other end. Okay friends, so before we go into that, so let us see a layered structure. Now, before you go into layered structure, let me give you some IEEE standards. They are very important in the exam, campus interviews, written examination, or orally you may also be asked by interviewer. What is 802.1? He will ask like this. 802 is one of the standard of your computer networking communication, which was designed by IEEE. IEEE is an organization who provide the following standards. 802.1 is nothing but LAN is formed, and point 2 LLC, logical link control. Point 3 is a MAC. Mainly I will write, remaining we don't require. And point 5 is ring, token ring. 4 is not that much important, or you want to go for 4, you can also go for it. that is the token bus, and 0.6 man, and 0.7, 0.8 not required, 0.10 and 0.11 is required. This is virtual LAN, this is wireless LAN, and 0.15 is required, Bluetooth, and 0.17 is packet ring. Remaining you don't require. There are around from 1 to 17 standards. Remaining don't require. These are all mainly important ones. Okay. In that, most important one is wireless and Bluetooth and token ring. Now you see, let us come to our chapter 2, layered structure. So what is a layered structure? Sender and receiver do not know that what is happening during the data transmission. The data will be transmitted using the layer concept. You see now, layer to layer, there will be a communication. This is 1, 2, 3, 4, known as layer n plus 1, layer n plus 1, layer n plus 1, layer n. This is layer n plus 1, layer n plus 1, layer n plus 1, 1, 2, 3, 4. This is your media. Okay. And every layer, horizontal, they have some protocol communication. They are being called as peers. And they are being called as service. Okay. So we have interfaces. One is a peer, the other one service. Peer interface will tell you how data is transmitted. And the service interface will tell you what operations to perform on protocols. Okay, just copy this. Now we see some of the important points about layering structure. Just please note it down, take a note. Layering structure provides abstraction and encapsulation. Layering structure provides abstraction and encapsulation. Next point. Every layer is associated with protocols. Next point. Layers and protocols builds network. Layers and protocols constructs network. Next point. Every protocol must follow protocol stack. A protocol stack is allowed only one protocol at a time. Next point. Layers are associated with interfaces. There are two interfaces, peer and service. There are two interfaces, peers and service. Layer to layer communication must be done. Layer to layer communication is done using protocols with the help of peers. Next point. No layer can transmit data on its own. No layer can transmit data on its own. Next point. Data and control flow. Data and control flow must comes from upper layer to lower layer. Upper layer to lower layer. Next point. Layer N is responsible for actual transmission. Layer N is responsible for actual transmission. Next point, all upper layers are involved in virtual communication. All upper layers are involved in virtual communication. The data which is received by lower layers from upper layers, data which is received by lower layers from upper layers is known as PDU. PDU stands for Protocol Data Unit. Next point, PDU consists of data plus control information of upper layer. Data plus control information of upper layer. So look at this, friends. What is an idea? So sender and the receiver, whenever you're transmitting data from layer 4, that will come to layer 3, that will come to layer 2, that will come to layer 1. Layer 1 is responsible for transmission of data other side. That means the layer 1 is involved in actual transmission. All other layers are involved in virtual communication. Okay. Now, as the rules which I gave you, which are belongs to layered structure, layering structure are few varieties. One is based on ISO and another one is based on IEEE. So layer types, one is open system interconnection, which is provided by International Standard Organization. The other one, TCP over Internet Protocol, is provided by IEEE. So most of the questions you will get from TCP/IP. So first let us understand what is open system interconnection. It is 7 layers, theoretical or referential model. Reference model. The layers are grouped into 3 varieties: group 1, group 2, group 3. Group 1 layers are known as end-to-end layers. Group 2 layers are known as layers are interconnected. This is interface to group 1 and group 2. Okay, let's copy this. We'll continue. So now let us see what is the group 1 layers and what is the group 2 layers. When you talk group 1 layers, they are layer 7, layer 6, layer 5. This is application, presentation, session. When you talk about group 3, layer 4, which is transport layer. And when you talk about group 2 layers, they are layer 1, layer 2, and layer 3. This is a physical layer. This is a data link layer. This is internet layer. This is an interface between this and this. Okay. And why the topmost layers like 765 are called as end-to-end layers means these three are end-to-end layers because they not deal with the media. That is a very important point. And the transport layer is also end-to-end layer, no doubt, which is also not deals with media. But these three are interlinked together. Interlinked together or chaining each other or deals with media. This is the structure. Now you observe carefully. Every layer has its own PDU. Yes or no? That is the point I said. Every layer has its own PDU. PDU stands for in which form the data is transmitted. In which form data is transmitted. For example, let me write here application layer APDU in the form of a message. Is a very important campus placements. Very important. Presentation layer PPDU, presentation layer protocol data unit, which is encrypted or compressed message. Session layer SPDU in the form of checkpoints. Transport layer protocol data unit, which is in the form of segments. Okay friends, just copy them. We'll see the rest of the three PDUs. Let's copy this. Now let's see the rest of the three PDUs. The PDU, as I told you, how the data is going to be pushing from that layer to other layers. Other layers in the sense other layers of the same standard. So internet layer PDU is IPDU or network layer protocol data unit or internet layer protocol data unit. It is in the form of a packet. And data link layer is a DPU. It is in the form of frame. And the present physical layer, the PDU is PPDU in the form of bits orientation. And now what is our idea is, whenever sender sends some data to down the layers, finally the data will be transmitted in the form of signals to other side. So as far as open system interconnection concerned, how it is happening, let us see. So here is the sender, application layer, presentation layer, session layer, transport layer, internet layer, data link layer, physical layer. Finally media. Here also physical layer, data link layer can communicate with data link layer, internet layer is also same, TL to TL, SL to SL, PL to PL, AL to AL can communicate with other standards. These are interconnected each other as the standards of hardware. Okay. Now you see, as I told you, lower layer has to provide services to upper layer. If at all it is a bidirectional communication, full duplex, keep arrow both sides. Lower layer has to provide services to upper layer. That's the important point. Lower layers has to provide service to upper layers. Okay. So this is layer number 7. 6 has to provide services to 7. 5 has to provide services to 6. 4 has to provide services to 5. 3 to 4. 2 to 3. 1 to 2. Here also 1 has to provide service to 2, 2 has to provide services to 3, 3 has to provide services to 4, 4 has to provide service to 5, 5 has to provide to 6, 6 has to provide to 7. As we know, the PDUs, APDU, it can communicate only with PPDU here it only communicate with SPDU, other side SPDU, and TPDU, NPDU, and DPDU, and PPDU. Here also same, PPDU, and DPDU, NPDU, and TPDU, and SPDU, and PPDU, and APDU. Okay. As we know, between what are the protocols? Dot dot. This is a protocol standard like this. So this is how they are able to communicate each other. So I said Abstraction. Main motto of layering structure is abstraction. What is abstraction? Whenever user sends some data that is in the form of a message, and here data will be in the form of encrypted, here in the form of checkpoint, here in the form of segment, here in the form of packet. You have to remember this, very important in campus interviews as well as in written examination, technical. So whenever sender sends data that is in the form of message, this is further in the form of encryption. This is further in the form of checkpoints. This is further in the form of segment. This is further in the form of packet. This is further in the form of frame. This is further in the form of bits. This is how your data is being protected from other layers. That's the concept of abstraction. So abstraction is try to cover your data. This is how at the sender. Receiver side, they will be broken. See here, first message, observe carefully, message, encryption, checkpoints, segments, packets, frames, bits. Reverse. What is the reverse? First, bits will be observed, then frames will be happen, then packets will be observed, then segments will be observed. Reverse, it will happen. Then checkpoints will be observed, then finally decrypted, and finally you will see the message. This message will be handed over to receiver. Understand, friends? This is how it happens with the layered structure. As I mentioned, some of the protocols here, because the horizontal interfaces are mainly called as I told you, peers. Peers are completely working with the protocols only. Okay, let's copy this. Yeah, well friends, now let us see encapsulation. So how encapsulation and decapsulation taking place with the layering structure? Now you see, whenever sender transmits some data to application layer, before it goes to the receiver, this process will go like this. So this application layer, for example, the data which is pushed by sender is high. Application layer adds its control info in the form of header. And now that will be pushed to presentation layer. Presentation layer takes the total, now it becomes a PDU, protocol data unit, which consists of data as well as headers of upper layer. So PDU consists, please remember, PDU consists of data and headers of upper layers. And it adds its own header, presentation header, which consists of encrypted protocol, what is encrypted key and all. This consists of what is the protocol the application layer is used, like HTTP or HTTPS or STP or DNS. This will come to next layer. Now it will take complete PDU now, which consists of your HAI high followed by your headers. Now it also adds its own header. Session header. Now the data will come to transport layer. Now entire PDU will be taken over. It adds its own header. It takes entire PDU now. And it adds its own header. Then data will come to next layer. This is your payload now. Which adds its own header, and it also adds trailer. Then data comes to next layer. This is your payload. Now the physical layer receives completely control info of other layers, and this will be pushed to media. So what do you understand? Attaching headers. Who will do? Layers which side? Center side, known as encapsulation. Reverse. If frame is successfully arrived correctly, without errors, then data link layer header comma trailer is removed. Okay, then rest will be handed over. If a packet is arrived without errors, then IH is removed. Next, this is done at respective layer. If segment is arrived correctly, then TH is removed. Same SH, decryption, then AH also removed. AH removed by application layer. Finally, HAI is received by the receiver. Now you see, so DLL, IL, TL, SL, PL, AL, message to message. Now the other side happened. The other side is what happened? Headers are removed. Every layer is responsible to remove its own headers. That's why this is called as a what? Decapsulation. Encapsulation is adding the headers. Decapsulation is detaching the headers. Okay friends, copy. This is how encapsulation and decapsulation is responsibility by layers. Now we will see what is the responsibility or what are the main responsibilities of each layer. We already seen what is the meaning of abstraction and encapsulation. Now we will see about functionalities of each layer. So when you talk about application layer interface to sender, receiver. It deals with high level protocols. Can you guess few protocols of application layer? HTTP, HTTPS, FTP, SMTP, POP, IMAP, TFTP, so many. Its PDU is APDU in the form of message. APDU is unlimited, very important. Why? You can type or you can send use message. There is no restriction to that. Next one, application layer adds header. Next point, application layer of sender communicate with application layer of receiver. It is app to app based. These are the main important points of application layer. Well friends, we'll continue the rest of the layers responsibilities in the next session. Stay tuned viewers. Thank you very much.